All right, so today we're going to talk about writing balancing chemical equations. So let's get started. So an example of a chemical equation or a chemical reaction, and by reaction I typically mean a chemical change, is when hydrogen and oxygen react together to form water. So how we're going to do, we're going to represent it this way. So you've probably seen this kind of thing before, but we're going to sort of dissect it and look at what the various parts are. So here, the things on the left-hand side of the equation here, these are the reactants. They're the things that we have to start with. They're what come together to react, and they react to form the products. The products are on the right-hand side of the arrow. So reactants and products are divided by the arrow, right? So reactants on the left, products always on the right. So that's how we separate them. Now, what's written in each of the products are the actual observed elements and compounds and chemical species that we see, and each separate reactant is separated by a plus sign. And if we'd had more than one product, we'd separate it by a plus sign also. So it's important to know that what we're writing here, the substances that we're showing, are what are actually observed. So I observe that hydrogen and oxygen come together to make water. That's what I observe. So the subscripts, you may have noticed these little letters down here, G, G, L. What they actually represent is the physical state or the physical phase of each substance. So G, as you might suppose, is a gas. L is indicating that something is a liquid. S is a solid. And then we have something called AQ. And what this means is aqueous, meaning it's dissolved in water. So you may have noticed these numbers over here, the 2 and the 2 here. Now what they represent, they are sort of the ratios, how many of each react. So what this means is 2 hydrogens reacting with 2 oxygens, two hydrogen molecules, 2 H2s, reacting with 1 O2 to make 2 water. So to draw this out, you'd see, let's just do H2, H2, 2 of them, plus 1 O2 to make 2 separate water molecules, right? So that's what those numbers are referring to. So let's jump back ahead. So that's what it means. Now the coefficients, based on the law of conservation of matter, meaning that substances, atoms can't be created or destroyed, we have to have the same number and type of atoms on each side of the equation. So atoms can neither be created nor destroyed. Atoms are just simply rearranged. So every atom that's in the products or reactants must be represented in the products, and vice versa. So if the written equation follows the law of conservation of matter, we call it balanced. Now, in real life, actual reactions always follow the law of conservation of matter. They must. Atoms can't just be destroyed. So what we're trying to do is we're trying to match our equation to the reality of the situation. Now, sometimes we'll be given an equation that is unbalanced. Now, notice, so let's take stock of what we've got over here. So we're going to take stock of the situation, and let's take a look. So we've got, on the left-hand side, on the reactant side, so remember reactants are over here on the left, I've got how many carbon atoms? I have 3. I have 8 hydrogens, so 3 carbons, 8 hydrogens, and 2 oxygens. On the product side, altogether, I have only 1 carbon, I have only 2 hydrogens, but I have 3 oxygens, right? So 2 here and 1 here. So this is not balanced. We have 2 carbon atoms vanishing into oblivion. We have, 8 hydrogen atoms running off somewhere, and then we have an oxygen atom that just appeared and became into existence somehow. So this doesn't really work. Now, what I am certainly not allowed to do is I cannot just change this to a 3. I'm not allowed to do that because that's not what we observe, right? I didn't see C3H8. I didn't see propane reacting with ozone, O3. I saw it reacting with O2, oxygen gas. So I can't change the subscripts. I'm not allowed, right? Because that changes what reaction we're talking about. The only thing I can do to bring it into balance is to change the coefficients out in front. Right? I can add numbers. Nothing right now in front is assumed to just 1. So we know that this doesn't just react as one propane molecule for one O2, producing one CO2 and one H2O. That doesn't work that way, because that doesn't follow the law of conservation of matter. Remember, we can't just take, magic tweezers and take one molecule of propane. So where we have one molecule of something, we've got billions of billions of them. So what I'm going to do is I'm just going to adjust the ratios so that it works. So unlike drawing Lewis structures, this is something I can't just give you a step-by-step thing on and have you do it correctly every time. Because remember, Lewis structures, it was do step A, step B, step C, and do it all in order, and you'll never get it wrong. Balancing chemical equations is a little more trial and error and a little more fluid like that. I can give you some guidelines. What I tend to do is I balance one element at a time. So I pick an element and balance it. And I try, the best elements to start with are ones that only appear once on each compound, right? So like in this example, carbon is a good one, or hydrogen is good. Carbon only appears in one compound, hydrogen only appears in one. Oxygen would be a crappy one to start with for 2 separate reasons. One, it's in everything on the right-hand side. So if I tried to balance oxygen first, as soon as I tried to balance another element, I would unbalance oxygen again, and it would be a problem. The other thing is, oxygen is by itself here, right? That makes it really easy to balance at the end without unbalancing anything else. So generally, anything that's in lots of different compounds on either side or both sides, I usually leave to be the last element I balance. And if it's by itself in the elemental form anywhere, I leave that to be the last element that I balance. So here's how I'll begin. You could start with carbon or hydrogen. It doesn't really matter which one you start with. Carbon, the way I could balance carbon is I have 3 over here in propane. I need 3 over here. So if I put a 3 in front of carbon dioxide, now the carbons are balanced. And I'm not worrying about the oxygens right now. I'll leave that to the end. Hydrogen, there's 8. I have 2. So take a moment, think about what number you'd put in front of water here. Hopefully you said 4. Right? So now I've got my carbons, 3 and 3, hydrogen, 8 and 8. And now the last thing I have to do is balance the oxygens. So let's take stock of how many oxygens we have now. Each CO2 molecule has 2 oxygens. Multiply that times the 3 carbon dioxide molecules I have is 6 total. Each water has 1 times 4 is 4. So 6 plus 4 is 10. How many O2 molecules do I need to get that? And the answer is 5. So now this is balanced. So I can see I've got 3 carbons, 3 carbons, 8 hydrogens, 8 hydrogens, 10 oxygens, 10 oxygens. And so now it's balanced. All right, so I want you to pause it, take a second, and try balancing these equations, and then we'll do it together. Okay, so let's take a look at this first one. What elements do you think would be good to balance first? Well, really any of them would be good, but chlorine and bromine will be easy to fix at the end. So let's take a look at sodium first. Sodium, well, sodium's already balanced. 1 sodium, 1 sodium, right? Let's just do bromine next. Why not? Either one is fine. Bromine, there's 1 bromine here. There's 2 bromines over here, so I need to put a 2 in front of sodium bromide, right? Now that unbalances sodium at the same time. So one thing you can do, by the way, you can keep a little tally going of what all of your elements are on the left and right side. So you can do sodium, there's 2 now, bromine, there's 2 now, chlorine, there's 2, and over here there's 1 sodium, 2 bromines, and 1 chlorine. And so now I have to change something else. And you can see that I need to put a 2 in front of sodium chloride. So now I've got 2, 2, and 2. Now this methodology, this is really good for helping you to begin with. But one thing I got to say is on exams and quizzes, you're not going to have 10 minutes to balance every equation. And sometimes when you first start doing this, you tend to be slow. Using this helps you be more accurate, but it is slower. So this is good to help practice when you're doing the homework, but you need to practice enough that you don't need to use this anymore. You need to get faster at it. And the only real way to do this is to practice, practice, practice. One other thing, it can be kind of trial and error sometimes. So what you want to do, sometimes you'll get caught in this weird loop where everything you do is screwing up everything else. Sometimes you just have to stop and start over from a different point and say, I'm going to balance this element first this time. So this next one is kind of weird. So I've got potassium, chlorine, and oxygen. So on the left-hand side, I have 1 potassium, I have 1 chlorine, and I have 3 oxygens. On the right-hand side, I have 2 potassiums, I have 2 chlorines, and I have 4 oxygens. So usually, a lot of times, oxygen is what I leave to last, but this time, I want to balance oxygen first, because potassium is in everything. Chlorine is in everything. Oxygen will actually be the easiest one. So what I'm going to do is so I've got 3 over here, I've got 4 over here. The only thing I can really do is get the lowest common multiple of 12. So I need 4 potassium chlorates, right, which gives me, this changes everything over here, right? This changes potassium to 4, chlorine to 4, and oxygen to 12. Now, the potassium perchlorate over here, I need 3 of them, right? Because that will give me 3 potassiums plus 1 is 4, 3 chlorines plus 1 is 4, and 12 oxygens. And lo, without even touching the potassium chloride, we've managed to balance the equation. So now we know we've got it balanced. All right, last one. And so I'm gonna do this without putting the little tallies down here. So calcium's already balanced, 1 and 1. Let's look at hydrogen. Hydrogen, I've got 4 here, 2 here, but also 2 here. It's already balanced, right? Also, don't forget, you probably want to leave hydrogen until last. Now, oxygen is the only one that isn't balanced. That's it. I've got 1 oxygen here, and I've got 2 here, because remember, this 2 is going to carry through to the hydrogen and the oxygen. So the only thing to do is I've got to put a 2 in front of water. That's all I can do. So now I've unbalanced my hydrogens by balancing my oxygen. So now I have 2 and then 4, so that's a total of 6. That's a fairly easy fix. I already have 2 here, 2 here. I just need to put a 2 here. So let's check everything. 1 calcium, 1 calcium. Hydrogens, 2, and then 4 here, so that's 6. 4, and then 2, that's 6. Oxygen, 2, and 2, we're totally balanced. So you want to practice this. This is going to be very important for the next thing we're going to be doing. Remember, everything is going to cascade on itself. So, want to keep practicing.